Welcome to a very short video that is focused on showing different scan inspection examples using the ScanINSPECT system. The ScanINSPECT system is sold under a variety of different names, including ScanSTENCIL and ScanSTENCIL Lite, all three of which are ScanCAD International products. As you all probably already know, ScanCAD has been around for 30 years. We're currently in 53 countries with over 3,000 customers with these systems installed. Our website is scancad.com, but we also have the website stencilinspection.com. For the purposes of this short video, we're really focused on stencils. So this overall ScanCAD product suite slide shows all of the different inputs and all the different outputs, if you will, or processes that ScanCAD offers solutions for. For this video, we are focused on using the flatbed scanner with the Solderpaste stencil and CAD data. CAD data in this case would either be DXF or Gerber data that has been imported to be used to inspect stencils. Yes, we are focused on 100% inspection with the goal of improving and assisting with process control on today's manufacturing floors. So it sort of level sets with you as far as what this video is about. We will be using this hardware today. This is our ScanINSPECT system on the left, again ScanSTENCIL or ScanSTENCIL Lite. As you can see, we have a Solderpaste stencil on the desk. Our transmissive light unit, our top light if you will, is over the stencil, pushing light down through the apertures to the scanner located below. This is an image of the scanner on the right. The scanner is actually located in this bench or desk underneath the desk, with the surface of the scanner just slightly above the surface of the desk. The glass calibration plate used to calibrate this system is also stored in a tray or a shelf below the scanner in a protected way. Those of you with this system know that this is either a sit-down or stand-up bench. It has adjustable legs here, so it's sort of what you need for your facility. Again, a little bit more on the hardware here. This is a contact system, so the scanner or the stencil is actually touching the surface of the scanner. So if the scanner faces up, the part faces down. In this case, we will be imaging stencils of the examples I'm about to show you. So the stencils are actually touching the surface of the glass. When we're inspecting wet parts such as printed solder paste, epoxy glue, or maybe three-dimensional objects like wire bonds and whatnot, inspecting those, we'll be using the focus capability of the scanner, and we will be using some sort of a standoff, so we actually will not be touching the scanner with that wet material. The lighting can be either top or bottom, and the examples I'm going to show you, we'll be using both top and bottom lighting. In one case, just top lighting. Again, top lighting, this light here is also called transmissive. Transmissive lighting, reflective would be the bottom lighting, the light coming up from the scanner. Again, this system is a calibrated system, so it meets the NIST certification, National Institute Standard Certificate of Conformity, NIST traceability. We will be, again, inspecting against Gerber data, which could be DXF. Today, I won't be in these examples showing you inspecting against golden parts, but that certainly is possible. The standard inspection process for a stencil takes approximately 5 minutes, and this is when every inspection is a new part number. So if you're bringing new part numbers to this system, it takes approximately 5 minutes for an average inspection. Why? Because we first need to import the Gerber data associated with that job, scan the part. If we are using reflective lighting, we will be color separating. In other words, we'll be extracting the parts of the image that we would like to inspect, and I have one example of that today with a step etch stencil. We will then overlay and align the image. In many cases, we can use the automated functions of the system if the Gerber data and the scanned image are the same size. We then perform an inspection, review any errors, and create a certificate. This report can be a paper report, a digital report. It also can be output in data that's compatible with Excel or your statistical process control system. So again, this is if every inspection is a new part. There is another video that will show our advanced functions, which if you have more than one part number being inspected, then you would simply use the scan and inspect same part again. So it eliminates the need to import Gerber data. It eliminates several steps in this process, so we can even reduce the average inspection time to below 5 minutes. By the way, this 5-minute average inspection time is measured by our customers with typical stencils in the field. Certainly there are stencils that take much longer than 5 minutes to inspect, extremely large stencils or stencils with very large aperture counts, of which I have one here that I'll be inspecting for you in a couple of minutes that has 340,000 apertures. So that does take longer than 5 minutes. All right, we're going to start with a simple stencil here. Again, this is the ScanCAD software. If you were to come into work, and if you were to run the function over here, if you came in and you would load a new job, for example, if you come up to the system with a new stencil to be scanned, many of our customers are using barcode today, barcode readers, and so they will use the barcode reader to zap the barcode on the product, which will load the job name, right? The part number, possibly even a serial number, if you will. It's sort of how you set up your job. So you'll put in the job name. In most cases for stencil inspection, you want to scan the image and you want to import the Gerber at the same time. So when you click these both here and operate, now you'll have a choice of scanning, of course, in color, monochrome, etc., transmissive lighting, reflective lighting, all those things. Again, I won't go into detail in this short video here, but essentially you are scanning and importing, performing that function, and when that happens, you will receive an image like this. The blue image is the scanned image. If you get in close on this image, get in really close on this image, you can see that it's pixelated. This is a raster image. This is a scanned image. Whereas the Gerber part of this image is green. And if you get in close on these guys, you can see that I can actually snap to this aperture, and at the bottom of the screen you can see that this is a rectangle with a Gerber decode of 129, and this is the size. The units again can be in metric or imperial or inch units, if you will, whatever you would like. Okay, so for the purpose of this short video, we're going as fast as we can. So again, we've imported the Gerber, we've scanned the image, we did that from the main menu. The next step is to overlay and align. There is an icon over here that automatically overlays and aligns the image, the Gerber data on the image, as long as they're the same size. If they are not the same size, then you will move through these functions here, which will flip, rotate, and move the data around over the image so that they can be overlaid nicely. You then run the final line where you check your corners, and I believe this comes in pretty, yeah, so you can see it comes in very, very good here. I can turn off the green on top of the blue there, and we can see this upper corner is in great shape. I'll come to the lower left corner. We can see that this is indeed great shape. If there was any kind of skew or rotation, this is the icon that's used to eliminate any skew. So again, imported the Gerber, scan, run the automatic overlap if the data is the same. This encourages you to have the data be the same when you import this data. So in other words, when you have data prepared for inspection, try not to have a step and repeat image of 1,000 different stencils or possibly logos or some sort of title block or other kinds of data that would make the Gerber data a different size than the stencil. If you do that, again, it's okay. It just involves a couple extra steps there. When you are ready for inspection, there is something called, well, this is the icon here for inspection, and this is something called Gerber comparison check. If you use the auto detect feature, what it's going to do is it's going to look at all the apertures in the after table and select the inspection level that is appropriate for this stencil. Again, each customer has the ability to create their own recipes and to inspect at different inspection levels that they like. I'm running in mil format now, so you can see my inspection levels are all in mils. If you're running in metric, you would actually have your inspection levels in millimeters or microns. In this particular case, it auto-detected at the 4 mil level, okay? And we'll go ahead and perform an inspection. By the way, in more detail, we can talk about these other features here in a different video. Again, I'm attempting to go fast. Also, the histogram is a very nice function, but again, we won't waste time on that right now. So essentially, when you run this function, it performs an inspection. It compares all the Gerber data against the scanned image. It found a total of 57 errors. If you look at the errors at the bottom of the screen here, you can see that it numbers them from, in this case, 3 to 57. If I hit next, it's 4 of 57, 5 of 57, etc. And every time I move, it's moving me to an error cross. I can hit, here it says N for next, P for previous. So I'm going to go to error number 1, the first error, and zoom in. Okay? So here I am at the very first error, and I have Gerber data where there is no raster image. So in other words, I've got a stencil that is missing an aperture for some reason. If this is a brand new stencil, perhaps the laser did not cut this aperture out, or there was some other problem when they were creating the stencil. If this is an existing stencil, the aperture could be blocked with some solder paste or some other foreign object, if you will. In this particular case, this happens to be a stencil where the aperture was completely missing. Why do I know that? Because the aperture next to it actually had some partial laser cut. There was some cut on this, so there's some light coming through an aperture here and no here. So this is probably a situation where there was some sort of a power surge or problem with the laser, and so that aperture was not cut. Now again, I'll zoom out. I'll go P for previous, previous. So those are the first two apertures up there. So next. The next aperture you can see that it's jumping to is over here, and we have an alignment issue with all of these apertures. So here the CAD data is aligned to the right relative to the actual stencil. So this kind of a problem we typically see on a manufacturing floor when an incorrect release of Gerber data is being used against the stencils. For example, you might have a Rev 1 Gerber data against a Rev 2 stencil. Perhaps there was an engineering change at some point where the CAD data was adjusted for a stencil, and this is a Rev 2 stencil. So this could be the situation, or again, there could be some sort of a, if this is a brand new stencil and the revs are correct, this could be some sort of a CAM error, some sort of a CAM error when creating the cut data. So the stencil data, for some reason, was shifted to the left relative to the CAD data. Regardless, this is a very serious issue and one that should be resolved before the stencil is put into production to understand what in the world happened here. I will skip forward through these errors here and run to the next error. This is typically an error, the type of error you would see in a BGA when cleaning was not sufficient. So we have a partially blocked aperture here, a completely blocked aperture here. So that's what it looks like when solder paste is blocked in the apertures of a BGA. Again, we have a different alignment issue with this PLCC device, etc. So I believe that's the errors for this job in general. Just really, those are the key errors that we had here. So if you are complete with this, and unfortunately this stencil is not one that you want to put in production, perhaps you just want to go ahead and if it was blocked apertures, to clean them. In this case, obviously, we'll have to order a new stencil to have a new stencil fabricated to do a fix here. There is another thing that can be done for stencil fabricators. If indeed these apertures did not drop, there is the ability to go ahead and create a rework file. So I'm highlighting that on the menu right now for a stencil fabricator. So you can create a rework file. If I hit F1 for help, you can see how this function works. Essentially what it's going to do, it's going to create a file that only has the Gerber apertures in it that did not get cut for some reason. That way, this stencil can be put back on a laser, and these two apertures can be cut in precisely the correct position, so the stencil does not need to be scrapped and thrown away. Okay? Again, very valuable for stencil fabricators. For stencil users, we hope that you never get to a situation where you receive a stencil like this, where the stencil apertures did not drop. For the stencil user, the important errors and the important learning here is cleaning. When you clean a stencil, to inspect it prior to going back into production. Ideally to inspect it before you store the stencil while you're still in the cleaning process, but if not, at a minimum, inspect the stencil before it goes into production to avoid potential solder paste defects in production and all the added value and cost of having that happen. Okay, again, the stencil system here, ScanINSPECT, is designed to be used by stencil fabricators as well as stencil users. When the inspection is complete, part of that 7-step process we talked about, the next step is to go ahead and create an inspection report. Okay, so basically I'll just say inspect report. Okay, now you could have this serial number here, and again the operator has the ability to enter this or use the barcode reader if they wish, and it will go ahead and create a text file. This text file is something that can be edited. So in the text file, I'll go ahead and enlarge this so you can see this. The text file has header information. It has the name of the job, the date and timestamp, potentially a serial number as you can see here if it was entered. It also indicates what type of inspection was done, how many apertures, what inspection level, when it was last calibrated, all of those kinds of things. All of the recipe, if you will, that was used. The operator is able to go ahead and put in their name right here. So they can put in their name into the document if they wish. It's however you would like to do that for your operation. Hopefully, in most cases, you don't have any errors. But in this case, obviously, we have our 57 errors. And you can see they're in a comma-separated format with the header information above that permits you to import this into Excel or your statistical process control system, so you can have this as part of your internal processes for your facility. Okay, so that is the text document that we have output. At the time of doing this, you also have the ability, if you wish, to go ahead and print. And I'll go ahead and print this to a PDF document, but you have the ability to go ahead and print an image. And again, I'll just call this inspect doc again, or inspect stencil. You can print, and when you print, you have the choice of outputting a raster image, the image here with error crosses, and we can go ahead and print this one-to-one, if you will, or obviously you can reduce it or enlarge it as you wish. It's a function of the stencil you're working with. And this will go ahead and print an image of the stencil, so this can be used again by a rework station or other type of a situation. Okay. I would like to also share that there is another way to handle your errors as well, is that you can also export errors in a color document with boxes if the stencil was scanned in color. And I'll show that to you when we do the color stencil here in a couple of minutes. So there you have it. We've gone through this process. We imported the Gerber, scanned the board, overlaid and aligned the data, ran the inspection, looked at the errors, and printed an output document. Again, the process here is typically 5 minutes, and that is the process we just went through for this stencil. Okay, right down to creating the certificate report, and also all of that data has now been saved for traceability and for your QC department, maybe your monthly or weekly meetings and that type of thing. Okay, let's go now and look at some other stencils, and we'll even go faster now as we move through this. We'll go ahead and quit out of here. And of course, you want to save all the data you did, so you simply would say yes normally. In my case, since this is just a video, I am not saving the data, but you would normally save that and it would be archived. Okay? Let's go ahead now and move over to a more interesting stencil. I mentioned that we would do a wafer bump stencil. This one is the one that has over 340,000 apertures. Actually, at the bottom of the screen, you can see 342,605 apertures. And if I get in close a little bit, you can see that we have a huge number of apertures here. And if I just snap to one, at the bottom of the screen, we can see that these are 3 mil apertures, or going to metric, 76 micron apertures. 342,000 of those. Now, as I zoom out, you can see there's a lot of apertures here. If we wanted to run the same inspection function, the Gerber comparison check. We could do that again and run through these. I'm going to go ahead and use a different inspection function. Again, part of this is showing you that with the ScanINSPECT system, there are many different inspection functions. Gerber comparison check is the one most of our customers are using. In the case of wafer bump stencils or stencils that have over 100,000 apertures, and again, we do have masks that we are inspecting that have over 1 million apertures, in some cases over 2 million apertures, especially with our Japanese customers who are inspecting those masks that are used on smartphones. So again, essentially it's just like a stencil, but instead of printing solder paste, they're using this as a mask for smartphones. For those situations, we have something called small aperture check. Again, I'm going to hit F1 here, just to show you that there's a definition of the small aperture check, and this context-sensitive help is available throughout the software, talking about every function here. So any place you are in here, you can go ahead and hit that for assistance. But if we go ahead and select this, we have a different kind of inspection. Instead of searching for aperture or errors that are 1 mil or 2 mil or 5 mil or 100 micron or 200 micron, we're now looking for defects in a different way, from very fine to very coarse. Again, I'm not going to spend much time on this, but just know that it's just a different inspection capability. And one of the reasons we do that is that it, in the case of wafer bump stencils, it really speeds up the inspection process. So you can see we just inspected 340,000 apertures literally in just a few seconds. Okay. There were 130 errors. If I zoom in and hit that previous, and the next and the previous, and so we'll just go to that first error, I'll turn off the CAD data and get in very close so we can see what's going on. Now in this case, just to let you know, this is a real live customer example, this wafer bump stencil. This stencil at the time of fabrication inspected perfectly. It's a good stencil. It was a good stencil. It was used in production, and it's going through a cleaning process. And during the cleaning process of these 342,000 apertures, some of the apertures still have solder paste in them. So this one here, the next aperture, and you can see there's a little bit of light coming through. This next one, completely blocked, completely blocked, completely blocked. And yes, right here, you can see we have some coming through with a little bit of blockage here. So, and by the way, this is someone had inspected the stencil previously, and they inspected in window. So they were just looking in this one specific area. And if I go over here, you can see that. You can always click on this, inspect in window if you want, okay? And that's true with all of the inspection functions, that we have the ability to inspect in window, so you don't need to inspect the entire stencil if you don't want to. But anyway, in this particular case, if I zoom around now and zoom out, you can see that we have solder paste blocking 132 different apertures out of 340,000 apertures. Okay, what does that work out to be? Let me go ahead and divide that right here. Divided by 340,000 apertures. So you can see that we are 99.9999% good. Okay. Okay, 99.9999% good. But if you look at this, you can see that if you actually use this for printing balls on BGAs or solder paste on BGAs, that you actually will have almost 100% loss of your BGAs. There are only like 1, 2, 3, 4, possibly 4 BGAs that don't have an error, a missing ball. That is horrible. So you can see how important this is to run this through the ScanINSPECT system. Again, I could do the reporting here and all of that again, which we won't bother doing. Let's do another example. We're going to, I have a second wafer, but I'll tell you what, let's just move forward for the for the ability to move fast here. We have a sample stencil that has a step edge feature. Okay, a step edge feature. So what I'm sharing with you here now is, let's go back to the PowerPoint just for a second. So you can see, import the Gerber, scan the part. If we're scanning in color, we need to color separate the features the features that are to be inspected. Only if it's a color scan. If I'm using that transmissive light and not reflective light, they're light from behind, then I just put light through the apertures. I'm scanning in monochrome and I don't need to do this. In the case of scanning in color, which I need to do if I want to inspect stepped features on a stencil. So if we come over here and let's go ahead and look at this stencil, very simple little stencil, and you can see here that they have a feature. Let me turn off the color separation. So if you were to scan this, you can see here that we have and those of you who've been trained on color separation, by the way, you'll see here that we actually, you can see the little pixels in the window here from where the color separation was done. So we were grabbing the pixels that we wanted and the pixels that we don't want. Again, I'm not talking about color separation now for this short video, but for those of you who've been trained on color separation in ScanCAD, you know that it's a very simple process saying this is the color I want, this is the color I don't want. In this case, I want to inspect the step etch feature and I want to inspect the cut feature here. So what we've done is we've color separated, so we now have the stencil openings we want to inspect, and we have the step etch feature we want to inspect. So just like before, we will put the CAD data on top. So just like before, we import the Gerber, we scan the image in color, we have that extra step of color separation, right, where we color separate the image. And by the way, I should share with you that most customers go ahead and store that as a stored color separation. So when they scan this type of stencil, they just load the color separation. I'll show that to you up here, color separation. They would load the color separation that matches this stencil type, this type of metal, okay? So if you're using a certain kind of stainless with a step etch, then you just run with that. If you also in your facility are using some sort of a plastic stencil, you will have a different color separation for that. So if we just perform our stencil inspection again, comparing the Gerber against the CAD data, we see right away we have some errors. If I turn off the Gerber data here for a second, we can see we have 2 errors here. So what has happened is that there are supposed to be 3 step etch fiducials here, but there's only 2, or only 1 actually. So here's the Gerber data, and there's no feature there. I can turn the color image on, and you can see that we do not have a step there, and we do not have a step here. So clearly this is a stencil that should not go into production or should not be shipped to the customer. Again, you can report the output, etc. Again, we could create a rework file, and this could go over into the, put back into the machine to have these etched features taken care of. Okay, so I'm going to go ahead and quit out of here, and we're now going to show one other example for this video, and something we do recommend, and that is just like before when you perform your inspection, we go through this process, we will overlay the Gerber data, we run through the process of inspecting. Go ahead and inspect this, and we can see if there are any errors. Just a standard stencil, we see that there are 4 errors, and if I come in close, we can see what these errors are. Here we have that same laser cut problem we had before. Okay, here we have some sort of alignment issue like we did before. And error number 4, we still have this blocked aperture or something like we did before. So you're all used to this, okay? Well, what's different about this inspection is that we have the ability to also add a second Gerber layer. So I'm going to turn off the scanned image, right? This blue image I can turn off at the bottom of the screen. And if we zoom in, we can see that we have on layer 2, I have put the original Gerber file prior to modification. So you have this ability both as a stencil fabricator and a stencil user to perform an extra inspection if you want that will compare the 2 different Gerber files. And we have the benefit, if we want, of actually having the stencil in the background as well. So this is much more powerful than just using a CAM package. We actually have the stencil in the background as well as the 2 Gerber files. That is done under the inspection menu. It's one of the 15 or more different inspection capabilities we have, and that's to do a Gerber to Gerber check. So just like before, you have the ability to inspect at many different levels. Now in this case, remember your data has been modified. So for example, if I inspect at the 4 mil level, we see that we have over 9,000 errors. Practically every aperture on the board has violated the 4 mil threshold. Why? Because the Gerber data has been modified, right? Has been modified to make the stencil. The actual stencil cut file has modifications where they're actually smaller. Okay? And even with your eye, you can see that we even have some other situations here going on. So let's now go ahead and run that inspection again, but this time let's run at, let's say, a 6 mil inspection level. Okay? So what we have is we have a situation where the data, we have cut data that somehow got modified so that the stencil data does not have that. Now if I put on the raster image, we also see that that didn't get cut on the raster either. But anyway, we have a situation here where it didn't get in the cut data, therefore obviously it did not get into the final file, into the cut file. That is a serious problem when you have a modification like that where an aperture is dropped. There are other situations here where there may be the modification was okay or not. This was a situation where the Gerber data was reduced a lot, and perhaps that is just fine. Okay, so there you have that, and that's it. Those are the errors that we have here. And what we've done today is just given you a few different stencil examples, a short video just on stencil examples. There will be other videos. We will do the same kind of thing for emulsion screens. We will do it for inspecting adhesive, epoxy, glue. We'll do the same thing for LTCC and aluminum or alumina type ceramic, print inspections, etc. Also printed solder paste, printed epoxy, printed glue. So the idea of this video is just to have a video that's targeted towards someone who is inspecting stencils. Since you are interested in stencils, we will bring up this SMT magazine article, which is relating a huge benefit of using ScanINSPECT to make sure that the stencil is going to match the PCB before you make the stencil. So we recommend you take a look at this. Just by doing this, we have this Motorola study, published study from 2006, an old study, but nevertheless very powerful, showing that if you modify the stencil data to match the board before you make the stencil, you can receive a 43% reduction in solder paste defects. We have a customer just a few weeks ago, summer of 2020, that is doing, we have many customers doing this, but they related numbers to us where they not only were reducing their solder paste defects in a huge way, but also all of their tombstoning and other issues have been dropped dramatically by doing that. This is a graph showing that benefit from the Motorola study, just by modifying the stencil data to match the job lot of board. Again, can ScanCAD do that? Absolutely yes. Your ScanINSPECT system has the ability to do that. We have a variety of options that can help with that and many other things, but just letting you know that that's a different video that you can look up if you'd like, where we actually make that adjustment to achieve those 43% reduction in solder paste defects. For the purposes of this video, there are 3 different options I'd like to talk to you about just a little bit before we close out. The first is the transmissive lighting option. This is the option that is really recommended for those wafer bump stencils or for that mask inspection where you have hundreds of thousands, if not millions of apertures. This is a transmissive lighting option. We have 2 different ones. There is a clamshell option. This one is primarily being used by our Japanese customers at this time. There are many, many units in Japan, and these guys, again, are inspecting apertures that are smaller than 50 micron. It's my understanding they're below 20 micron apertures, and they are using this. We also are detecting pinholes less than 12 micron, and even down to 5 micron now, pinholes, using this transmissive lighting option. It says no competition. It's a really unique offering from ScanCAD International. In the case of the other lighting option, the one that was used for the wafer bump stencil you just saw, we have a less expensive transmissive lighting option called the TLP3. Essentially, it's a scanner lid with a light inside that fits right on top of the scanner. It allows you to turn the light on and off, everything under software control inside the ScanCAD software. Great solution. It works very well for those types of stencils that can fit on an A3 scanner. If it's a larger part, then the clamshell is a better offering. Another thing I wanted to share with everybody for ScanINSPECT is if you have a higher volume operation where throughput is very important, we have a product called ScanSolo. So instead of buying maybe 10 different ScanINSPECT systems, you could actually purchase, well, you still may want to purchase 10 of the ScanSolos, but you don't have to buy 10 of the ScanINSPECT systems, because the scanning part of the 5 minutes is the biggest part, okay? You can see how fast it is for me to do the inspections in front of you. So really what we're waiting for is the image capture. It's capturing the image of the stencil. That is the slowest part, especially for very high resolution situations like those Japanese customers or people doing wafer bump stencils. Those machines are being run in clean room environments today. They are using ScanSolo today with the clamshell, and essentially each machine is scanning the board. So they're all scanning in different parts of the facility, and that data is now going over to an inspect module. There's a ScanSolo scan module that does the scanning. There's a ScanSolo inspect module where the inspection takes place, possibly in an engineer's office or someplace else on the factory floor, maybe not even in the clean room, for example. So the images are all captured by serial number, and the images are processed in a different room. So this really increases your productivity and throughput using the ScanCAD system. It is very modular. There's obviously a price performance benefit because it's lower cost than a full ScanINSPECT system if you're able to do this kind of breakup, if you will. It also provides some redundancy. So there is some backup, obviously, if you had a scanner failure, though I should say that it's incredibly rare that our scanners fail. We have scanners that are running out there for over 25 years now. In production environments. Very, very rare. Scanners are only damaged when they're moved around. So that's the two different lighting options and the ScanSolo option. This is now the metrology option, metrology software called ScanMeasure. This is another package that we strongly recommend you consider adding. Just a little bit of extra money can be added later if you wish, if budgets don't permit. But the ScanMeasure option permits you to have your metrology capability right on your ScanINSPECT system. So you have the kinds of capabilities that you only see on a $50,000 US or more expensive metrology system. Also, you get that full traceability you have with ScanINSPECT. All of the images, all of your measurements are all captured and stored safely. Not only the report that you're outputting, but all the images and the measurements are captured and stored. So really cool. It is using the same exact hardware, so that same glass grid, that same scanner. The system has a very large field of view compared to traditional, let's say, camera-based measurement metrology systems. We now have really an A3 size field of view. We capture the entire image, so a large field of view versus the typical half-inch or 1-inch square inch type of field of view that you would have with a scope or a camera-based system. We have a full 12 by 18-inch field of view, and the images we're handling here can be, based on scan resolution, up to 2 or 3 gigabytes in size. The ScanCAD system has no trouble handling that. So essentially, you are able to move through and measure diameters and widths and all point-to-point measurements and all this good stuff. You can add all kinds of notes and annotations on here. All of these things can be taken back against tolerances, measured to against drawings and whatnot. All that you would expect in a typical metrology type system. The output is, again, something that, well, here is a sample output here that you can modify here before it actually gets output into an Excel type format, a comma separated file. So great traceability, very powerful measurement, a low cost software option. So there you have it. This is a short video talking about stencils, stencil inspection, showing some stenciled examples. And really, as you can see, it ties in with these other benefits that are all related to ScanCAD systems from around the world. So it's been a pleasure to share this with you, and we look forward to hearing from you if you have any questions. Thank you so much.